This is the lesson on proving perpendicular lines. We started class today by looking at a warm-up in which you are trying to identify if essentially two lines are perpendicular or parallel. You need to find their slope if you're given it on the coordinate plane. For example, this slope here, it's a point here, and the next place it goes through whole numbers would be here. So the slope here would be rise 1, run 1, 2, 3, 4. So it is a positive rise 1 over a positive run 4. Then we can look at the slope on this one. See, again, you're looking for 2 points, so there, and it looks like here's our next place. So we're going to go down 1, 2, 3, 4 units over 1. So this one is down 4, so n is down 4 over 1 units. Now if you look here at our two slopes, we have negative 4 over 1, and we also have 1/4. These are opposite in value, and they're reciprocals. When you have opposite reciprocal slope, you have perpendicular lines. If the slopes were the same, something like this, then the slopes would both be like n equals 2 and n equals 2. If the slopes are both the same, then what you have are parallel lines. So slopes that are the same result in parallel lines. Slopes that are opposite reciprocal result in perpendicular lines. We also talked about some important theorems. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So suppose you have two intersecting lines, and they form a pair of congruent, so this is congruent to this, then what we can say is that these two lines are perpendicular, meaning they're going to be forming those 90-degree angles. We also have in a plane, if a transversal is perpendicular to one of two parallel lines, so here's parallel lines, here's transversal, and it's perpendicular to one of the lines, then it is also perpendicular to the other. And then this theorem here says that if you have two coplanar lines that are perpendicular to the same line, so here we have this line is perpendicular and this line is perpendicular to the same line right here, then the two lines are parallel, which means this will end up being a transversal, and these two lines are parallel. So if they're both perpendicular to the same line, it results in parallel lines. We also had some important vocabulary in which we did a perpendicular bisector. That's if you have something like this, where you have segment A and B, and then you slice it directly in half with a perpendicular line. It's perpendicular, and it bisects this into two equal segments at that midpoint. You were given a problem in which you had to solve for x and y. Now when you look at this here, we have this theorem that says if we have two parallel lines and one of the lines is perpendicular, then the other is also perpendicular. So now we know that this is a 90-degree angle, so what we can do for this first one here is say 2x plus the 90 degrees is equal to 180. So we'll subtract 90 from both sides, so 2x equals 90. Divide both sides by 2, so x equals 45. Then you're going to repeat the same process, but this time now we're going to look. If these two lines are parallel, then these two angles have to be equal to each other. Or you can also say, I know that these two right here are going to add up to be 180. We'll just go with that. So 3y minus 2x plus the 90-degree angle should equal a straight line 180 degrees. Subtract 90 from both sides. We get 3y minus 2x equals 90. We already know that x is valued here at 45. So we get 3y minus 2 times 45 equals 90. This right here is 90, so 3y minus 90 equals 90. Add 90 to both sides, 3y equals 180. Divide both sides by 3, and y will equal 60. Finally, we have a two-column proof here. And again, always with a two-column proof, you're going to start with your given. So R is parallel to S, as well as angle 1 is congruent to angle 2. And the reason? That is given. If you look at the picture here, if R and S are parallel, that means angle 2 and angle 3 have to be congruent. Angle 2 is congruent to angle 3. Why? These are corresponding angles. So we have the corresponding angles postulate that says that if you have two parallel lines cut by a transversal, the corresponding angles are congruent. Well, then you can look at this. We have angle 1 is congruent to 2, angle 2 is congruent to angle 3, so therefore angle 1 is congruent to angle 3. Why? Well, we just used the transitive property. Well, if I know angle 1 and angle 3 are congruent to each other, I also know that line R is perpendicular to line T. Why do I know that? Well, when I have two intersecting lines that form a linear pair of congruent angles, then the lines are perpendicular.